For months, the sky looked calm, too calm. Out beyond the planets, drifting along the flat plane of the ecliptic, an interstellar object moved exactly as the models predicted. No sudden turns, no strange bursts, no reason to worry. On paper, it was perfect. Astronomers watched it the way they watch thousands of objects every year. Quietly, patiently, almost on autopilot. Another visitor from another star system. Rare, yes, but not impossible. Space is full of travelers. Most pass through without leaving a mark. This one was given a name, logged into databases, slotted into simulations. And then the waiting began. Night after night, telescopes followed its slow path across the dark. A faint point of light against a background that hadn't changed in billions of years. The kind of observation that feels routine. The kind that never makes headlines. At first, nothing stood out. The brightness rose and fell just as expected. Distance explained everything. Angle explained everything. Motion explained everything. The object was still far from the sun, far from danger, far from answers. But everyone knew what was coming. Perihelion. The moment when the object would pass closest to the sun. The moment when heat, radiation, and solar wind would test its true nature. The moment when even ordinary space rocks reveal their secrets. As perihelion approached, instruments grew more sensitive. Exposure times adjusted. Filters changed. Every photon mattered now. This was the phase where certainty usually sharpens, where data locks into place, where the sky stops being mysterious and starts being measurable. And then the first light curve arrived. It should have been simple, a smooth rise in brightness, a clean arc, a curve that matched the math almost perfectly. But this one didn't. The line on the screen bent, not dramatically, not enough to trigger alarms, just enough to make someone pause. A slight distortion, a hesitation, as if the light itself had stumbled. At first, it was easy to dismiss. A calibration issue, atmospheric interference, a misaligned sensor. Someone reran the numbers. The curve stayed wrong. Another observatory checked their data. Same distortion. Different instruments, different locations. Same strange bend in the light. The sky wasn't behaving the way it was supposed to. Still, no one panicked. Science trains you not to jump to conclusions, especially when the universe has embarrassed confident humans before. So the object stayed classified as normal. The anomaly stayed labeled as minor, and the waiting continued. But something had changed. Not in the sky, in the room. People began leaning closer to their screens, scrolling back through older data, comparing this object to others like it. The more they looked, the less comfortable they felt, because the distortion wasn't random. It appeared at the same rotational phase, at the same orientation, at the same point in its slow, silent spin. Light was reflecting differently, not brighter, not dimmer, just wrong. As days passed, the object crept closer to the sun. The solar glare increased. The environment grew harsher. This is where comets usually start to show their weakness. Ice cracks, gas vents, dust clouds bloom. You see chaos. But this object remained clean. No tail, no debris, no visible shedding. Just that faint, stubborn point of light, holding its shape. And still, the light curve refused to behave. Each update brought the same subtle hesitation, the same gentle break from expectation. It was like listening to a familiar song and realizing one note is always just slightly off, enough to notice, not enough to explain. Somewhere between routine and concern, a quiet question formed. What if this isn't an error? What if the sky isn't glitching? What if the object is? The thought stayed unspoken, because saying it out loud would mean crossing a line from observation into implication. Instead, scientists did what they always do. They waited. They watched the sun rise higher in the object's sky. They watched radiation climb. They watched models strain to keep up. Perihelion was getting closer, and with it, the moment when uncertainty would either collapse or explode. Late one night, another batch of data came in. Higher resolution, cleaner signal, less noise. This time, the distortion was undeniable. The light curve wasn't just bent, it was segmented, as if brightness changed in steps instead of flowing naturally, not jagged, not chaotic, controlled. A silence settled over the lab. No one rushed to speak. No one joked it away. They all knew the same thing. Nature doesn't usually do this. Rocks tumble. Ice boils. Dust scatters. But this looked intentional. Still, no headlines were written. No announcements made. Because the greatest discoveries often begin with discomfort, not confidence. Outside, the sky looked the same as it always had. Stars steady. The sun rising and setting like clockwork. Nothing about the night warned anyone that something unusual was unfolding. But up there, moving silently toward the most violent object in our system, was something that didn't quite reflect light like it should. And as perihelion drew closer, the waiting sky seemed to hold its breath. Was this just another strange rock from another star? Or had humanity just noticed the first crack in a much larger pattern? The data kept coming. The answers did not. And somewhere in that silence, the discovery was already beginning. The numbers arrive quietly. No alarms, no flashing warnings. Just files stacking up from observatories across the world. Chile, Hawaii, the Canary Islands, Australia. Different skies, different instruments, same target. At first glance, it looks normal. Columns of data, rows of decimals. Brightness values measured down to impossible precision. This is the part of astronomy no one talks about. Not the wonder, not the beauty, just numbers. Cold, exact, unemotional. And yet, something feels off. Because when scientists begin to compare the data, it doesn't line up. The reflectivity values don't agree. One observatory reports the surface reflecting more light than expected. Another sees it darker, duller, almost absorbing light. A third shows fluctuations that shouldn't exist at all. Same object, same time window, same sun, different answers. At first, the explanation is easy. Calibration differences, minor timing offsets, instrument sensitivity. This happens all the time, so they correct for it. They normalize the data, adjust for distance, correct for angle and rotation. They run the models again. The numbers still don't settle. Instead of converging, they drift, as if the object refuses to be pinned down. Reflectivity should be boring, Most natural bodies in space follow simple rules. Rough surfaces scatter light. Smooth ones reflect it cleanly. You can predict behavior decades in advance. That's why these models exist. They've been refined for generations, tested against comets, asteroids, moons. They almost never fail. Almost, because this object keeps slipping through them. When the math says the surface should brighten, it darkens. When it should dim, it flashes slightly brighter. Not enough to scream anomaly, just enough to whisper it. The kind of whisper that makes scientists double-check their work, then triple-check it. Another observatory sends in fresh numbers. Higher precision, better signal-to-noise ratio. The result? Now the reflectivity shifts appear to depend on perspective. As if the object changes how it reflects light based on who is watching. That shouldn't be possible. Light doesn't care who measures it. Physics doesn't play favorites. And yet, the data suggests otherwise. The object seems to behave differently when viewed from different angles, even when those angles should produce identical results. Someone suggests surface irregularities. Another suggests tumbling motion, so they model that. They simulate every possible spin, every plausible shape, every natural explanation. None of them fit. The curves still drift, the values still slide, the numbers refuse to settle. As perihelion draws closer, the sun floods the object with energy. This should simplify things. Heat smooths behavior. Radiation strips away complexity. Nature becomes predictable under pressure. But instead, the discrepancies grow. Reflectivity changes faster now. Sharper transitions. Cleaner edges. Not random noise. Patterns. Small ones. Subtle ones. But unmistakable. One analyst notices something strange. When the object brightens, it does so in discrete steps. Not smoothly, not gradually, as if someone is turning a dial. Click, pause, click again. The room goes quiet, because that's not how rocks behave. Another scientist overlays the reflectivity changes with rotational data. The alignment is too clean. Each shift lines up with the same rotational phase, over and over again. This isn't a fluke. It's consistent. And consistency is dangerous, because randomness can be ignored. Patterns cannot. Emails start flying. Careful language, measured words. No obvious explanation. Further analysis required. Anomalous but inconclusive. No one uses the word impossible, not yet. But everyone feels it hovering in the air. As more data pours in, something unsettling becomes clear. The object isn't just reflecting light differently, it's doing so efficiently, almost too efficiently. Certain wavelengths bounce back cleanly, while others vanish. Selective reflectivity. That's rare in nature. Very rare. You usually see it in manufactured materials, in layered surfaces, in coatings designed for control. Someone points this out softly. No one argues. They just stare at the screen. Because now the question is no longer about errors. The math is solid. The instruments agree on one thing at least. Something about this object changes how it interacts with light, in a way that resists simple measurement, as if the act of observing it alters what we see. That idea makes everyone uncomfortable. Not because it's supernatural, but because it's familiar. This is what happens in controlled systems, in experiments, in machines, where feedback matters, where response depends on input. And suddenly, reflectivity stops being a surface property and starts feeling like behavior. Someone runs a comparison with known objects. Comets? No match. Asteroids? No match. Interstellar debris? Still no. The object sits alone in the data, a category of one. As perihelion approaches, the sun's glare intensifies. Signal quality should degrade. Instead, it sharpens, as if the object is compensating, adjusting, staying visible. That's when a quiet thought begins to form, not spoken aloud, but shared in glances. What if the object isn't resisting measurement? What if it's responding to it? The idea feels dangerous because it shifts the frame. From passive object to active participant, from thing to system. No one writes that in a report. But the numbers say it anyway. They say, this object does not behave like matter alone. They say, observation does not settle it. They say, the more precisely we look, the stranger it becomes. Outside, the sun continues its ancient burn, unaware, uncaring. Inside, screens glow late into the night. Rows of decimals, refusing to behave, and for the first time, a deeper question takes shape. If the math is right, why does this object act like it doesn't want to be fully seen? And what happens when perihelion forces it into the brightest light of all? At first, no one notices it. It hides inside the noise, buried between error bars. Lost in fluctuations so small they barely register. Just a faint rise, a slight fall, the kind of thing scientists are trained to ignore. Because space is noisy. Detectors drift. Photons arrive unevenly. Most irregularities mean nothing. But this one keeps coming back. Night after night, as new brightness data arrives, a junior analyst spots something strange. Not dramatic, not obvious. Just a rhythm, a soft, repeating pattern in the light curve. At first, it's written off as coincidence, a rounding artifact, a sampling issue, a ghost from the instrument. So the data is cleaned, smoothed, filtered, corrected. The rhythm survives, still faint but stubborn. The brightness rises, drops, then rises again, at even intervals. Too even. The analyst overlays the last 3 observation windows. The peaks align perfectly. That shouldn't happen. Natural light curves are messy. Even rotating objects wobble slightly. Imperfections always creep in. But this looks timed. The finding is sent quietly to a senior researcher. No excitement, no bold claims, just a simple note. Seeing a repeating structure in the residuals might be worth a look. Hours later, another message comes back. I see it too. Now the room feels different. The data is pulled up on a larger screen, axes adjusted, scale expanded. There it is, clearer now, a pulse, not a spike, not a flare, a gentle, controlled increase in brightness, followed by a clean return to baseline. Over and over and over again. The period is measured, then measured again. Same result. The pulse repeats at regular intervals. Seconds, minutes, hours. It doesn't drift. It doesn't decay. It just ticks like a quiet heartbeat. Someone jokes nervously. Probably rotation. It's the safest explanation. Rotation can cause repeating brightness changes as surfaces reflect light differently, so they test that. They compare the pulse period to the object's estimated spin rate. It doesn't match, not even close. They adjust the model, change assumptions, try irregular rotation. Still no match. The pulse remains independent. Another possibility is considered: jetting. Some comets vent gas in rhythmic bursts, but there's no gas, no dust, no tail, nothing to cause brightness changes from expelled material, and the pulses are too clean, too precise. Natural outgassing is chaotic. This is not. As the data grows, something unsettling becomes clear. The pulse strengthens near perihelion, not by much, just enough to notice. As solar radiation increases, so does the clarity of the rhythm, almost as if the sun is powering it. That idea makes people uneasy, because now the pulse isn't just a curiosity. It's reacting to environment. One researcher runs a blind test. They mix the data with noise from other objects. The algorithm still finds the pulse every time. Another overlays the pulse timing with thermal data. There's a correlation. Not perfect, but suggestive. The brightness peaks align with slight thermal shifts, as if energy is being absorbed, then released, slowly, deliberately. No one says the word signal, but everyone is thinking it. Because this is how signals behave. They repeat, they persist, they survive noise. And most importantly, they don't need to be loud. The pulse isn't broadcasting. It's whispering, a pattern hiding in plain sight. Someone asks the question no one wants to ask. What are the odds of this happening by chance? The answer comes back quietly, extremely low. Not zero, but close enough to matter. They widen the search. Old data. Earlier observation runs. The pulse is there too, weaker. Harder to see, but present. It didn't start recently. It's been there the whole time, waiting. The realization sends a chill through the room, because that means the object didn't suddenly change. We did. Our instruments got better. Our attention sharpened. The pulse didn't appear. It revealed itself. As the sun looms closer, the pulse remains stable. No distortion, no collapse. That alone is strange. Radiation usually disrupts delicate patterns. But this one holds, as if protected, or designed to endure. A senior scientist finally breaks the silence. If this were intentional, this is exactly how you'd hide it. Not in radio waves, not in bright flashes, but in data no one expects to carry meaning. Light curves are boring, until they aren't. The team debates internally. Could this be some unknown physical resonance? A new class of interstellar object? An exotic surface property? All possibilities remain on the table, but the pulse keeps time, unaffected by doubt. Tick, tick, tick. The sun burns brighter now. Perihelion is close, and with it, maximum exposure. If the pulse is fragile, it should break. If it's accidental, it should drift. If it's noise, it should disappear. Everyone waits for that moment. But the pulse doesn't vanish. It sharpens, becomes easier to see, cleaner, almost confident. And that's when the fear quietly settles in, because coincidence fades with repetition, and patterns that survive stress usually exist for a reason. The object continues its silent fall towards the sun, unaware or uncaring of the humans watching it. or perhaps aware enough to keep time. The pulse keeps beating, the light curve keeps whispering, and a question now hangs over every new data packet. Is this just another strange behavior of the universe? Or have we finally noticed that something out there is keeping a rhythm of its own? A rhythm that doesn't belong to chance. A rhythm that waits as perihelion approaches for whatever comes next. The closer it gets to the sun, the less sense it makes. This is the point where most objects fail. Radiation rises fast. Temperatures climb without mercy. Ice boils away. Rock cracks. Metal softens. Nothing survives perihelion unchanged. Everyone knows this. So when the first thermal readings arrive, no one is surprised. At first, the object is warming, slowly, too slowly. Solar energy is pouring into it, flooding its surface with heat strong enough to tear molecules apart. And yet the temperature curve lags behind. It's as if the heat is being held back, absorbed, delayed. Someone mutters that maybe the surface is porous. Another suggests unusual composition. Fair enough. Nature can be strange. But then the next reading comes in, and the temperature drops. Not gradually, not smoothly. It falls fast, too fast, faster than any known material should allow. Heat doesn't just vanish, it dissipates, it radiates, it bleeds away over time. But this looks like regulation, as if something is controlling the flow. The team stares at the thermal graph. Up, down, up again. Tight cycles. Repeated. Clean. Someone overlays the thermal data with the brightness pulse from earlier. The alignment is unsettling. When brightness peaks, heat shifts. When brightness drops, temperature follows. They aren't perfectly synced, but they're related, as if part of the same system. As the object pushes deeper toward the sun, the environment becomes brutal. Solar wind lashes at it. Radiation slams into its surface. This is where fragile things die. Yet the object holds together. No fragmentation, no debris cloud, no sudden flare of gas. It remains intact, and the thermal behavior becomes even stranger. The surface warms, but not evenly. Certain regions heat up while others stay cool. Not because of shadows, not because of rotation. The pattern doesn't match geometry. It matches timing. Heat appears, pauses, then vanishes, like breath. In, out. Someone finally says what everyone is thinking. This shouldn't be possible. Not as a panic, as a fact. They run simulations. Every known material, every known structure. Solid rock, metallic core, carbon-rich body. None of them behave like this. Either they heat too fast or cool too slowly. There is no natural combination that explains both. The object is breaking the rules in both directions. As perihelion draws closer, the sun fills half the sky from the object's perspective. Temperatures should spike uncontrollably now. But instead, the peaks flatten. The highs stop rising, almost like a ceiling, a limit. The object refuses to cross it, and then something even stranger happens. During one observation window, the sun's output increases slightly, a normal fluctuation. The object's temperature responds, but not immediately. There's a delay, a measured delay, then a correction. The heat drops back to the same range as before. as if the object noticed the change and adjusted. That's when the room goes very quiet, because thermal inertia doesn't behave like that. Passive objects don't respond. They endure, they suffer, they break. But this object seems to manage its exposure, like it's protecting itself. The phrase thermal control appears in someone's notes. It's quickly crossed out. Too loaded, too dangerous. Instead, the report says, unusual thermal behavior inconsistent with current models. Safe words, but the meaning lingers. As hours pass, perihelion is almost here. This is the moment of truth. If the object is fragile, this is where it dies. If the data is wrong, this is where reality corrects it. Everyone waits. The readings stream in. Temperatures rise. Radiation peaks. The sun is now an overwhelming presence, and still the object survives. No explosion. No collapse. The thermal curve tightens further. The cycles become cleaner. Almost refined. Heat in, heat out. Controlled, purposeful. Someone pulls up a comparison chart. Other objects at similar distances. They're not even close. Those bodies glow white hot. They shed mass violently. This one does neither. It stays within a narrow thermal band, as if it was built for this. That thought hangs in the air longer than anyone is comfortable with. Because surviving the sun isn't just difficult, it's one of the hardest tests in the solar system. Only things designed to endure extreme conditions pass through unchanged. And this object doesn't just endure, it behaves. The sun begins to recede. Perihelion has passed. This is when temperatures should slowly normalize, but the object cools rapidly, too rapidly, faster than before. Heat drains away with surgical precision. No lingering warmth, no slow decay, just a clean drop, back to baseline, like a system powering down. The data is undeniable now. Multiple observatories, independent instruments. Same result. The thermal pattern is real, and it defies everything we know about passive matter. Someone finally voices the unspoken question. How is it still intact? No one answers, because every answer leads somewhere uncomfortable, to engineered materials, to layered structures, to internal systems designed to manage energy, to things that don't just exist, but function. The sun continues its ancient burn, indifferent and violent. It has torn apart countless objects before. It has reduced mountains to dust. Yet this visitor passed close and emerged whole. Not scarred, not weakened, just unchanged. As if the sun tested it and failed. The data is saved. The graphs archived. Official statements remain cautious. But inside the minds of those watching, a shift has occurred. Because heat is honest. It doesn't lie. It reveals weakness, and this object revealed none. As it moves away from the sun, cooling faster than physics allows, a haunting question settles in. If this thing can regulate heat, if it can survive where nothing else should, then what exactly did we just watch pass through our system? And more importantly, why was it built to withstand the most violent force we know? For the first time, the focus shifts. Until now, everyone has been watching the object, its light, its heat, its behavior. But as perihelion arrives, something else enters the story. The sun, ancient, violent, unmoving in its authority. The sun doesn't react to small things. It swallows comets without noticing. It tears asteroids apart without slowing down. It floods space with power that bends planets into obedience. Nothing passes close to it and leaves an impression. Nothing. So, no one expects what comes next. As the object reaches its closest point, solar instruments begin recording routine data: magnetic fields, plasma density, solar wind velocity. Just another day of watching a star burn. And then a deviation appears. Small, barely noticeable. The solar wind bends. Not dramatically, not violently, just enough to be strange. Streams of charged particles that should flow straight outward curve, as if something is in their way. At first, it's assumed to be coincidence. Solar activity fluctuates constantly. The sun is restless by nature, so analysts check for flares. None. Coronal mass ejections, nothing significant. The sun is quiet, too quiet, and yet the data shows a distortion. Plasma flows ripple slightly around the object's trajectory. Magnetic field lines stretch, then tighten, like fabric pulled around a moving shape. The numbers don't scream. They whisper, and that's what makes them dangerous. Because big events are easy to explain. Small, precise changes are not. Someone overlays the object's position with solar wind maps. The alignment is uncomfortable. The distortion follows the object briefly, then disappears, as if the sun adjusted, then let go. In another dataset, particle density dips for a fraction of time near perihelion, not a collapse. Not a void. A pause, as if something disrupted the flow, and the sun corrected itself, or reacted. The question forms quietly. Is the sun responding, or is it being influenced? That question feels almost forbidden. Because the sun is the source, the dominant force. Everything else adapts to it. Not the other way around, but the data doesn't care about hierarchy. It only records what happens. And what happens here doesn't fit the story we're used to. As the object crosses perihelion, solar instruments watch closely. This is the most violent region of space in the inner system. Radiation is extreme. Fields are unstable. Particles move at incredible speed. Any interaction should be messy, chaotic. Instead, the disturbance is clean, brief, contained, then gone. No shockwave. No lingering turbulence. Just a subtle shift and silence. The sun resumes its normal flow as if nothing happened. Almost as if something passed through without leaving a mark. That alone is unsettling, because even empty space leaves turbulence behind. But this is like slipping a needle through fabric without tearing it. Some scientists argue the sun didn't react at all. They say the fluctuations fall within statistical noise. They point to decades of solar variability. They urge caution, and they're not wrong. But others notice something harder to dismiss. The timing. Every distortion aligns with the object's closest approach. Not before. Not after. Only during. As if the sun noticed, just for a moment. One instrument records a faint, localized change in magnetic orientation. So small, it almost gets filtered out. Almost. Another detects a brief asymmetry in plasma flow on the opposite side of the sun. That's harder to explain, because the object isn't even there anymore. And yet, the effect appears delayed, like an echo. The sun is massive, beyond comprehension. Signals take time to travel across it. Reactions are slow, and then overwhelming. But this reaction, if that's what it is restrained, measured, as if the sun adjusted, then decided not to escalate. That idea makes no sense. Stars don't choose. They burn, they erupt, they destroy, unless there's nothing to destroy. The object passes through perihelion intact. No flare reaches out to grab it. No eruption tears it apart. The sun remains strangely calm. Too calm. This is not the behavior seen when comets dive too close. Those encounters are violent. This one is surgical. The object doesn't fight the sun. It doesn't challenge it. It simply passes, and the sun lets it. After perihelion, solar data stabilizes completely. The distortions vanish. Magnetic fields snap back into place. Plasma resumes its usual outward flow. If someone hadn't been watching closely, they would never know anything happened. And that's the most haunting part. Because it means the interaction, if there was one, was subtle enough to hide. No scars, no evidence. Just a momentary hesitation in the most powerful engine we know. Later, someone compares the data to known solar interactions. Planets create long-lasting effects. Large comets cause turbulence. This object does neither. Its influence, if influence is the right word, is minimal but precise, like a whisper in a hurricane. One researcher writes a line in their private notes. Either the sun ignored it, or it didn't need to respond. They never include that line in the official report. Official language stays cautious. Minor, transient solar wind irregularities observed near perihelion. Safe, boring. But behind the scenes, the question won't go away. Because if the object truly caused those shifts, then it interacted with the sun. And if it didn't, then why did the sun behave differently at that exact moment? Both possibilities are unsettling. The sun is not just a background. It's a test, a filter. Anything unnatural should be exposed here, stripped bare, destroyed. But this object passed through, and the sun barely acknowledged it. As if it didn't register as a threat, or worse, as if it registered as something else entirely. As the object moves away now, cooling, quiet, unchanged, the sun returns to its endless burn. Nothing appears wrong. Nothing appears different. But those who watch the data know better, because for a brief moment, the most violent force in our system hesitated. And no one can agree on why. Did the sun react to the object? Or did it recoil from something it couldn't touch? The data offers no answer, only silence. And silence can be louder than any explosion. At first, it looks like a trick of geometry, a harmless effect of angles. As the object moves away from the sun, its orientation slowly changes. Different faces catch the light. Different surfaces turn toward Earth. This happens with every rotating body in space. Nothing strange about that, except, this time, the reflections don't glide. They snap. Sharp bursts of brightness flash across the data. Clean, sudden. On, off. Not smooth like a spinning rock. Not chaotic like tumbling debris. Controlled. At first, analysts assume it's a jagged shape, an uneven surface catching sunlight at odd moments. So they model that. They create virtual shapes, spikes, ridges, fractured geometry. None of them fit, because jagged surfaces create messy reflections, blurred peaks, uneven curves. This object doesn't do that. Its brightness jumps, then holds, then drops, like a switch. The reflectivity curve starts to look less like astronomy and more like engineering. Each burst occurs at a precise orientation, the same angles, every rotation. No drift, no decay, just repetition. Someone overlays the reflectivity bursts with rotational timing. Perfect alignment. Every burst happens when the object reaches a specific position in space, not when it faces the sun most directly, not when it faces Earth most clearly, but when it reaches a very specific angle between the two. That detail changes everything, because natural reflections don't care about observers. They only care about light, but this reflection seems to care about geometry, perspective, configuration, as if it's designed to behave a certain way, only under certain conditions. The bursts aren't bright enough to be seen with the naked eye. They don't announce themselves. They hide in the data. Polite, subtle, easy to miss. Almost like they're not meant to be obvious. Someone zooms in further. The edges of the bursts are sharp. Too sharp. Light usually rolls in and out as angles change. This doesn't roll. It clicks. Brightness increases abruptly, then cuts off just as cleanly. No fade, no blur. It's digital in spirit, even if the medium is light. The room grows quiet again, because this is familiar. Not from space, from machines. Reflective panels, layered materials, surfaces designed to redirect energy efficiently. You see this behavior in satellites, in probes, in objects made to manage light with purpose. Someone finally says it. This looks manufactured. No one laughs, no one dismisses it, because by now, unusual has been stretched thin. Too many things have gone wrong in the same direction. The object doesn't just reflect light, it modulates it. Certain wavelengths return strongly, others disappear. This selective behavior tightens as the object rotates, as if different regions are tuned differently. Not random mineral scatter, not accidental composition. Tuning implies intent, or at least design. They check polarization data. Another surprise. The reflected light shows structure, order. Patterns that shouldn't exist on a natural surface exposed to interstellar erosion for millions of years. Space is violent. Micrometeoroids sandblast everything smooth. Radiation degrades structure. Time erases detail. Yet this surface behaves like it's been preserved, or protected, or renewed. Someone suggests a natural crystalline structure. Rare but possible, so they search for analogues. None behave like this. Crystals scatter light. They don't gate it. Another suggestion. Metallic composition. But metals heat quickly. They don't survive perihelion intact without glowing uncontrollably. This object didn't. The list of natural explanations shrinks, not because they're impossible, but because they require too many coincidences at once. Perfect timing, perfect angles, perfect control. Nature is efficient, but it's not precise like this. As the object continues to rotate, the bursts continue. Steady, predictable, almost patient. One researcher notices something chilling. The bursts align with moments when observation quality is highest, when instruments are pointed most directly, when signal-to-noise ratio peaks, as if the object reflects most strongly when it knows it's being seen best. No one writes that down, but no one forgets it either. This isn't active communication. There's no message, no code, just behavior. But behavior can be louder than language because it tells you what something is built to do. And this object appears built to manage light, not simply endure it. At what point does strange become engineered? There's no clear line. Just a slow crossing. Reflectivity stops being a property and starts being a function. The object isn't shining randomly. It's selecting when to shine. Why? That question echoes quietly. As days pass, the bursts remain stable. No degradation from solar exposure. No surface damage. If anything, the reflections become cleaner, sharper, as if the harshest environment in the solar system did nothing to disrupt its surface logic. That's when the word machine starts appearing in private conversations, not as a claim, as a comparison. Because machines do this. They control energy. They redirect inputs. They behave consistently. Natural objects don't care about consistency. They just exist. This one behaves. The object moves farther from the sun now, cooling, quiet. But the reflectivity pattern doesn't fade. It persists, still clicking on and off at the same angles, like a signature or a fingerprint. Official summaries stay conservative. Unusual reflective behavior correlated with rotational geometry. Safe, neutral. But behind those words, a deeper discomfort grows, because reflectivity isn't something you evolve accidentally. Not like this. Not with this level of control. The universe is old, ancient, messy, and yet, passing silently through our system is something that treats light like a tool. As the object drifts farther away, the bursts grow weaker. Distance steals detail. Eventually, the pattern slips back into noise. Harder to see, easier to doubt. But those who saw it really saw it. Know one thing for certain. There was a moment, a clear moment, when the light didn't behave naturally, when reflection stopped being passive, and the question changed forever. If this object wasn't just reflecting the sun, but using it, then what exactly did we witness? And how many times before have we mistaken machines for rocks? Simply because we didn't know how to look. The object continues into the dark. Silent, distant, leaving behind no proof, only patterns and a line that can never be uncrossed again. Because once unusual starts to feel artificial, you don't unsee it. You just wait for the next reflection. The debate doesn't begin with shouting. It begins with silence. A conference room. Dim lights. Screens glowing with charts no one wants to look at for too long. Everyone here is careful, measured, trained to doubt their own instincts. Because science doesn't reward bold guesses. It rewards restraint. And yet, something has gone wrong with the usual order. The data is no longer arguing quietly. It's pressing. So the doors close. No live streams, no press releases, no quotes, just scientists. And the problem they can't ignore anymore. At first, the conversation stays safe. One voice says, it's an unknown natural process. Another mentions rare surface chemistry. Someone brings up interstellar weathering, effects we don't fully understand yet. These are reasonable ideas, comforting ideas, because they keep the universe familiar. Someone points to history, to how often science has been surprised before. How strange things eventually find natural explanations. Everyone nods. This is the script they know. But then, someone asks the wrong question. Not loudly, not dramatically, just directly. If this is natural, why does it behave like it's conserving itself? The room stills. No one rushes to answer. Because that question doesn't fit the safe explanations. Conservation implies awareness of limits, responds to threat, adjustment. Those are not passive traits. Another scientist clears their throat and reframes it. Thermal inertia can appear adaptive. That sounds better. But it doesn't explain the light pulses, or the reflectivity gating, or the sun's strange non-reaction. Another voice tries again. Maybe it's a new class of object, something we've never seen. That idea gains traction, a category we haven't discovered yet, a loophole in understanding. But then someone quietly adds, new classes still obey physics. And that's when the room starts to feel heavy, because physics has been stretched thin already. The models don't just struggle, they fail. One by one, charts are pulled up, cross-referenced, compared. Each anomaly alone could be dismissed. Together, they form a pattern. Someone gestures at the screen. Light modulation, thermal regulation, structural integrity near perihelion, consistent orientation-based behavior. They pause. This isn't random. No one disagrees, but no one agrees either. Because agreement would force the next step, the dangerous one. A younger researcher asks carefully, has anyone ruled out artificial structure? The word hangs there. Artificial. No one reacts at first, not because it's shocking, but because everyone has already considered it. They just don't want to be the one who says it. A senior scientist responds quickly, we don't have evidence for that. True, absolutely true. But then comes the follow-up. We also don't have evidence against it. That lands harder, because science is built on elimination, and nothing has been eliminated yet. Someone suggests caution. We must avoid projecting intention. Agreed. But intention isn't required for design. That's the uncomfortable truth. Machines don't need to think to function. They just need to work. Another scientist hasn't spoken once. They've been quiet since the beginning, staring at the data. Someone finally turns to them. What do you think? They hesitate, long enough to make everyone uneasy. Then they say, I think we're arguing about the wrong thing. The room listens. I don't think the question is what it is. A pause. I think the question is why it behaves as if it expects conditions to change. That's when the silence becomes complete, because expectation implies foresight, preparation, design with environment in mind. Not just the sun, but us, the observers. Someone laughs nervously. Let's not go there. But the idea doesn't leave. It can't. Because the object's behavior doesn't escalate when observed. It stabilizes. It cleans up. It becomes more precise. As if scrutiny sharpens it. That's backwards. Natural systems fall apart under stress. This one tightens. The conversation drifts again, back to safe ground. Publication language, peer review, controlled statements, no claims, no speculation, but the tension remains. Because there's a growing divide in the room, those who talk and those who stop. Some scientists become quieter with each new slide. Not skeptical quiet, concerned quiet. The kind of quiet that comes when your intuition outruns what you're allowed to say. Someone asks another dangerous question. If this were artificial, what would it be doing? No one answers. Because every answer feels absurd. Observation probe. Interstellar debris from an ancient civilization. Autonomous system with no mission we can detect. Speculation spirals too fast, so they stop it. We don't know, someone says firmly. That's the only honest answer. Everyone agrees, but honesty doesn't bring comfort. Because we don't know is different now. It's no longer about ignorance. It's about possibility. The meeting ends without resolution. No conclusions. No consensus. Just a plan to keep observing, to collect more data, to wait. As people stand and gather their things, conversations splinter into whispers, hallway discussions, private messages, carefully worded emails. Some insist the object will eventually make sense. Others stop replying altogether. And that's when the most telling sign appears. Certain questions stop being asked, not because they're answered, but because they're dangerous. Dangerous to reputations, dangerous to careers, dangerous to certainty. The loudest voice in the room never said a word. It was the silence that followed one question asked too directly. Not, what is it? But, what if it isn't supposed to be here by accident? That question doesn't make it into any report. It doesn't appear in any abstract, but it lingers, unwritten, unspoken. As the object continues drifting away from the sun, unchanged, unbothered, the debate remains unresolved. Officially, nothing extraordinary has been found. Unofficially, everything has changed. Because once a room full of experts goes quiet, it's not because there's nothing to say. It's because everyone knows exactly what saying it would mean. And no one is ready for that yet. The discovery doesn't come from new data. It comes from old files, archived, forgotten, buried under years of routine observation. After the debates stall, after explanations begin to circle the same empty space, someone suggests looking backward, not out of hope, out of habit. If this object is truly strange, then it shouldn't only be strange now. So they opened the archives. Years of sky surveys, wide field scans meant to catch anything moving, anything passing through quietly. Most of it is noise, cosmic dust, background stars, artifacts no one ever looks at twice. But this time, they know what to look for. They search for the pattern, the faint pulse, the strange reflectivity, the subtle timing that once hid inside error bars. At first, nothing appears. Then, a hit, a weak one, almost dismissed again. A small fluctuation in brightness from years ago. Logged, explained away as noise. The date matters. The trajectory matters. The object wasn't named yet. It wasn't important yet. But the signature is there. Someone zooms in, enhances the data. The pulse emerges, faint, but familiar. The same rhythm, the same spacing, the same quiet insistence. The room tightens. Because this changes everything. This means the behavior didn't begin near the sun. It didn't start under stress. It was always there, waiting. Another dataset is checked. Different telescope, different year. Same anomaly, missed again. dismissed again. A note in the margin reads, "Likely instrumental." That note now feels heavy because it wasn't instrumental. It was invisible until someone knew how to see it. The pattern repeats across multiple surveys, never obvious, never loud, always hiding just below certainty. Like it didn't want attention, or didn't need it. That realization is unsettling, because it means the universe didn't suddenly become strange. We just became aware. The object wasn't changing. Our perception was. For decades, astronomers have trusted their filters, their thresholds, their assumptions. They've learned to ignore subtle regularities because space is full of false patterns. Pareidolia is dangerous, seeing meaning where none exists. So the systems are designed to suppress it, to flatten faint signals, to erase weak rhythms, efficiency over curiosity. And that worked until it didn't, because now, with hindsight, the anomaly is obvious. Not glaring, but consistent. Someone overlays years of data. The pulse never stops. It weakens with distance, strengthens with proximity, but it never disappears. Like a lighthouse, seen only when the fog lifts. This isn't a one-time event. This is behavior. The implication settles slowly. If this object has passed through our instruments before, then how many others have we missed? Not because they were invisible, but because they didn't match expectations. Someone asks a quiet question. What if this isn't rare? No one answers immediately, because rarity is comforting. Singularity makes anomalies safe. But repetition changes the story. If the pattern existed before, it means we failed to notice it, not once, but repeatedly. That's harder to accept. The human mind wants the universe to surprise us, but not to watch us fail. And yet, that's what this feels like. Like something passed through our view, over and over, and we waved it away. The phrase observer bias appears in discussion. Normally, it's used gently, a reminder of human limits. But here, because the object didn't hide itself completely, it just didn't shout. It behaved in a way that required patience, attention, curiosity, traits not always rewarded in modern science. Someone points out something chilling. The anomaly grows clearer as instruments improve, as if it scales with observation, as if the better we get at looking, the more it allows itself to be seen. That idea is uncomfortable because it flips the relationship. We're not discovering it, we're catching up to it. The pattern doesn't change to match us, we change to notice it. Old skepticism gives way to something quieter, not fear. Recognition. The sense that this story didn't begin when we noticed it. It began long before perihelion, long before debates, long before headlines. It began the first time the object crossed a human instrument and left a trace too subtle to matter. Until now, the team digs deeper. They look for other candidates, other faint pulses, other strange reflectivity hints. A few appear, none confirmed, but enough to raise a question. Are these isolated events, or fragments of a larger pattern we don't yet understand? The universe hasn't changed. Our tools have. Our expectations have. And that might be the most dangerous shift of all. Because once perception changes, you can't go back. What was once noise becomes signal. What was once dismissed becomes suspicious. the sky doesn't feel the same anymore. Not because it's hostile, but because it might be active. Not reacting to us, just existing on a level we weren't tuned to notice. The object continues its journey now, fading, cooling, quiet, but the pattern it revealed doesn't fade. It spreads through archives, through conversations, through the minds of those who know where to look. The anomaly isn't new. That's the truth. It never was. We are. And that raises a final, haunting question. If this pattern has been passing through our sky for years, if it's been visible but ignored, then how much of the universe have we already looked at without actually seeing it? And more importantly, what else is out there right now, doing the same thing, waiting for us to notice that the patterns might be watching back? It doesn't begin with an announcement. It begins with a leak, a short paragraph, a cropped graph, a sentence taken out of context and dropped into the open internet. At first, no one notices. Just another post buried under headlines and noise. But then someone shares it. Then someone else. And suddenly, it's everywhere. Forums light up. Screens fill with the same image. A light curve that doesn't look right. A pulse that shouldn't be there. People argue at first. They always do. It's fake. It's misinterpreted. It's clickbait. Comfort lives in dismissal. But the data doesn't go away. More documents surface. Old presentations, slides never meant for public eyes. Words like anomalous, unresolved, inconclusive start circulating. Careful words, but to the public, they sound like alarms. Astronomy communities begin dissecting every pixel, every decimal. Amateurs recreate the analysis at home. Code runs overnight. Screens glow in dark bedrooms across the world. And then, something strange happens. They find it, too. The pulse, the timing, the same quiet irregularity. It's not proof, but it's enough. Enough to shift the mood. Disbelief turns into curiosity. Curiosity turns into unease. Because this time, the mystery doesn't feel distant. It doesn't feel abstract. It passed close to the sun, close to us. People start looking up at the sky differently, not searching for lights, not expecting answers, just looking. Social media fills with questions that don't have a place in scientific papers. Why didn't they tell us sooner? What if it's not natural? What if it noticed us? Scientists urge calm. They remind everyone that uncertainty is not evidence. That strange data doesn't mean intention. That the universe is full of surprises, all true. But reassurance only works when fear is loud. This fear is quiet. It doesn't scream. It settles. Late at night, people replay the idea in their minds. An object that doesn't speak, doesn't transmit messages, doesn't announce itself, but behaves, adjusts, persistes. The most unsettling thing about it is that it doesn't seem to care if we believe. It just continues. That changes something. For generations, humans have looked at the sky as observers, detached, curious, safe. The stars were distant. Objects were passive. We watched. They didn't. But now that boundary feels thinner, because this object didn't just exist. It responded. Not dramatically, not openly, but enough to suggest interaction. And once that idea takes root, everything shifts. People begin rewatching old documentaries, rereading history. How many times have we seen something strange and shrugged? How many signals were filtered out because they didn't look like what we expected? The sky becomes crowded again, not with ships, with possibilities. Astronomers feel the change too. Emails increase, interview requests flood in. They choose their words carefully, because now they're not just explaining data, they're managing perception. And perception is powerful. The object doesn't threaten. It doesn't approach Earth. It doesn't change course. Yet, somehow, it feels closer than anything before, because it doesn't need to act. It already did, by existing in a way that forces reflection. People begin asking deeper questions, not about aliens, about ourselves. What does it mean to observe? What does it mean to be noticed? What if awareness isn't one-sided? These questions don't belong to astronomy alone. They bleed into philosophy, into psychology, into late-night conversations between friends who never talked about space before. Something has awakened, not fear, attention, a sense that the universe might not be as indifferent as we thought. The object continues drifting outward now, fading, harder to detect, easier to forget. But forgetting doesn't come as easily this time, because once the idea of mutual observation enters the mind, it stays. We start to wonder if observation itself changes things, not physically, emotionally. If knowing you might be seen alters how you look back. Telescopes keep tracking. Data keeps flowing. Nothing dramatic happens. No final signal. No reveal. And that absence becomes its own message. Because silence isn't emptiness. Silence can be intentional. The public waits for confirmation, for denial, for closure. None arrives. Official statements remain cautious. Further study required. No conclusions at this time. But the human response has already moved beyond conclusions. It's moved into awareness, a subtle awakening. People stand outside longer at night. They stare at the same stars they've seen all their lives, but with a different feeling. Not wonder, not fear, something quieter. Recognition. The idea that the universe might not be a stage, but a shared space. The object never speaks, never explains, never acknowledges us directly. But it doesn't need to, because it has already done something profound. It has changed the way we look up. And once observation starts to feel mutual, you stop asking what's out there. You start asking, what does it mean to be seen? And are we ready for whatever looks back without ever saying a word? It doesn't end with a message. There's no flash, no burst, no final surge of light to mark the moment. The object simply keeps moving. Day by day, it drifts farther from the sun, farther from Earth, slipping back into the dark it came from. At first, the pulse is still there, faint but steady. Tick, tick, the same rhythm that once hid inside the noise. But now, something begins to change. The intervals stretch, just slightly, hard to notice at first. Then again, the pulse slows, not abruptly, not chaotically, gradually, as if winding down. Scientists watch closely. If this is a signal, this is where you'd expect something to happen. A final transmission, a peak, a goodbye. But nothing comes. The brightness still rises and falls, but with less urgency, less precision. The once sharp edges soften. The reflectivity bursts blur, as if the object is losing interest, or power, or purpose. Someone charts the decay. It's smooth, predictable, almost graceful. That's unsettling in its own way, because random noise doesn't fade like this. It collapses. This doesn't collapse. It resolves. The last clear pulse appears on a quiet night. No one notices at the time. It doesn't announce itself. It just happens. One final rise in brightness. Then, nothing. The next data packet shows flatness, no rhythm, no structure, just background light. The pulse is gone. At first, analysts assume interference. They check the instruments, all working. They cross-reference observatories, same result. Different skies, different sensors, same silence. The pattern that haunted months of observation has ended. The object continues moving outward, shrinking, dimming, harder to detect now, closer to noise than signal. And that's when the unease deepens. Because if this was a natural process, why stop now? Rotation doesn't simply end. Surface properties don't switch off. Nature tapers, but it doesn't conclude. This feels finished, as if a process has run its course, as if whatever was happening has done what it needed to do. People argue again. Some say the silence proves there was never a signal at all, just a threshold effect, just physics. Others disagree. They point to the timing. The pulse weakens only after perihelion, only after the closest approach to the sun, only after maximum observation. That sequence matters because it suggests purpose, not communication, completion. The object didn't speak, it didn't warn, it didn't announce itself. It simply existed, under specific conditions, for a specific window of time. Then stopped. That's harder to explain away. A scientist writes privately, "If it were a test, it's over." They never send that email. But the thought spreads anyway. What if the pulse wasn't meant for us? What if it wasn't a message at all? What if it was a process, a measurement, a scan, something that required proximity to a star and awareness of observers, and once those conditions were met, there was nothing left to do. The object moves past the outer planets now, its light barely detectable. The sky feels normal again, too normal, as if nothing ever happened. That normalcy is almost worse, because it invites doubt. Memory fades quickly when the universe goes quiet. People want closure. They want certainty. They don't get it. No signal is decoded. No explanation satisfies everyone. The silence refuses to clarify. And silence is ambiguous. It can mean nothing was ever there, or it can mean something was, and it's done. Both interpretations are uncomfortable. One reduces months of tension to error. The other opens a door with no handle. The final reports are cautious. The anomalous behavior diminished with distance. No further activity detected. True, accurate, incomplete. Because what's missing is the feeling, the sense that something ended, not failed. The object fades beyond reliable detection. Eventually, it's lost entirely against the background stars. No ceremony, no farewell, just absence. And absence is powerful, because it forces the mind to fill the gap Was the pulse a signal? Or was it simply the sound of a system operating, then powering down? Did silence mean lack of intent, or proof that intent had already been fulfilled? There's no answer. Only a lingering stillness, the kind that follows completion, the kind that makes you wonder if you were part of something, without ever knowing how. The sky goes back to being quiet. But it doesn't feel empty anymore, because once you've heard a pattern, even silence sounds different. And as the object disappears into the unknown, one final thought remains. If this was never meant to speak, then maybe the most important message was that it didn't need to. And if silence marked the end, what exactly just ended? And are we certain it won't happen again? The sky looks the same again. Stars fixed in their places, planets moving as predicted, the sun rising and setting without hesitation. To anyone looking up, nothing has changed. But inside the data, nothing has settled. The object is gone now. Too far, too dim, lost in the endless background of space. Telescopes point elsewhere. Observation schedules move on. New targets replace old ones. Officially, the chapter is closed. But the questions remain open, because the numbers don't resolve. They sit there, archived, labeled, carefully stored. Light curves that don't smooth out. Thermal graphs that never found explanation. Patterns that end but don't decay. Science is comfortable with mystery. It lives with unanswered questions every day. But this one feels different. Not because it broke the rules, because it bent them and then left. The sun continues its endless burn. Violent, ancient, unchanged. It has consumed countless objects before. It will consume countless more. And yet, for a brief moment, something passed close and came away untouched. That fact doesn't fade. It doesn't fit into footnotes or appendices. It lingers. Researchers publish cautious summaries. Words are chosen carefully. Unusual, unresolved, inconclusive. No one wants to overstep, because history remembers oversteps. Still, in private, conversations continue. Late-night emails, quiet calls, questions phrased as hypotheticals. What if we missed the point? What if this wasn't about us at all? What if it was never meant to stay? The object never changed course, never slowed, never approached Earth. It didn't announce itself. It didn't warn us. It didn't invite contact. And that might be the most unsettling part. Because we didn't matter, and yet we were included. Included as observers, as witnesses, as part of the environment it passed through. The sun was a test. Our instruments were a test. Our attention was a test, and whatever the object was, it passed. The universe doesn't feel hostile now. It feels aware, not watching us specifically, not targeting, just existing in layers we're only beginning to sense. The shift isn't in the sky, it's in perspective. Before this, anomalies were things to be solved, reduced, explained away. Now they feel like invitations. Not to panic, to look closer. The object fades completely from detection. Eventually, even its last trace becomes uncertain. Was it here, or did we imagine its importance? That doubt creeps in. It always does. Time dulls urgency. Memory softens edges. The human mind wants closure. But closure never comes, because closure requires answers, and answers require questions we're still afraid to ask. Did we witness a rare cosmic anomaly, a perfect storm of misunderstood physics, a reminder of how much we still don't know? Possibly, that explanation remains valid, comfortable, safe. But there's another possibility, quieter, harder to sit with, that this wasn't a message, or a warning, or a visitor in the way we imagine visitors, that it was simply something passing through, operating according to its own rules, briefly intersecting with ours. And in that moment, we noticed. The sun burns on. The sky stays silent. But silence doesn't mean emptiness anymore. It means restraint. It means patience. It means there may be things in motion that don't need our response or our permission. We didn't discover the universe is alive. We discovered it may not be indifferent, and that difference matters. Because once you accept that possibility, you stop asking when something will arrive. You start asking how often it already has. The object is gone. The shift remains. And every night now, when the sky looks calm again, there's a quiet understanding. That normal might only mean nothing unusual is happening to us. Not that nothing unusual is happening at all. And if this was the first moment we were noticed, not announced, not contacted, just noticed, then the real question isn't what comes next. It's whether we'll recognize the next moment when it happens again.